Hello students, so we have studied that decantation method cannot be used to separate salt and water components from its mixture. And why is it so? Well, it is so because if we add salt, so here you can see I have salt, and if I add this salt into water and thereafter if I stir it for some duration of time, then here you can see that salt, it dissolves in water, and we have learned that decantation is a process by which a liquid layer is separated from the sediment. So decantation method cannot be used to separate salt and water components, and that's because in this mixture we are not getting any sediments. But if decantation method of separation can't be used here, then how do we separate salt and water components from the salt-water solution? Well, in this case, we have to look out for some new method of separation. So you know what happens when water is heated? Yes, it begins to vaporize quickly, and very soon the particles of water, they change from liquid state to gaseous state. So you can see here the vapors of water arising right out of this beaker. Now similar thing happens when we heat salt water. So let's just first make a solution of salt. So here I add salt into this water and I'm going to make the salt solution. Alright, so we have made our salt solution right here. Now what is going to happen after some time? The water, it will evaporate away and we'll be left only with the salt particles at the bottom of the beaker. So let's just observe it for some time. And there you see the water, it evaporates away and we are left with only salt particles. And what is this process called, which helps us in separating a mixture of salt and water? Yes, it is known as evaporation. So the process of conversion of liquid water into water vapor before reaching its boiling point, that is 100 degrees Celsius, such a process is known as evaporation. Now many of you would be thinking that in this activity we had boiled the water. And if the water was not boiled, then how is it possible to change water into vapor without heating it to its boiling temperature, that is 100 degrees Celsius? So students, here I want to tell you that it is not always necessary to boil water to convert its state into gaseous state from liquid state. And that's because even at room temperature, water keeps changing into its vapor state. But that process, it occurs at a very slow pace. Now this evaporation takes place continuously wherever water is present, such as rivers, ocean, sea, etc. And do you know that these water bodies, they provide nearly 90% of the moisture in the atmosphere via evaporation. Thus, it is true that water boils at 100 degrees Celsius, but it can evaporate at any temperature from 0 degrees Celsius to 100 degrees Celsius. And the factors that increase the rate of evaporation, they are increase in temperature, increase in surface area, and finally increase in wind speed. Now detailed explanation as to how do each of these factors they affect the rate of evaporation, that will be discussed later in your higher classes. So you have understood that evaporation is the method by which salt and water can be separated from the mixture. Can you now give me an example from your daily life where you have observed evaporation? So one of the most common examples of evaporation is when we hang our wet clothes under the sun. Then after some time, they get dried. And how does it happen? Well, it happens as the water present on our clothes, it gets dried, it gets evaporated due to heat of the sun, thus causing drying of the clothes. Now, one more example of evaporation is sweating. Sweating plays an important role in cooling the body by allowing water to evaporate off the skin, thus resulting in loss of body heat. So these are some of the daily life examples of evaporation. And I think many of you would know that evaporation method is used for obtaining salts from seawater. And I think many of you would know that evaporation method is also used for obtaining salts from seawater. So you all know that seawater is not potable, which means it's not safe to drink because it contains large amount of various salts and other impurities in it. But students, it is the seawater only from where we obtain our common salt. And now some of you must be wondering, how do we get salt from seawater? Well, the answer to this is via evaporation. So when seawater is allowed to stand in shallow pits, water, it gets heated by sun's rays and slowly it turns into water vapor through evaporation. In a few days of time, water evaporates completely, leaving behind a mixture of solid salts. Thus, in this way, we get salt from seawater. And pure common salt is then obtained from this mixture of salts by further purification. So this is how we get salt from seawater by the process of evaporation. Now you might be thinking that why do we have to wait for days for evaporation to happen in the process of getting salt from seawater? Why can't we just boil the seawater and get the salt in limited amount of time? So students, boiling seawater won't give us salt in commercial quantities because requirement of salt for the whole country is very high. Secondly, getting salt from seawater via evaporation is a very cost-effective process as we do not have to spend a large amount of money for supplying heat energy and in buying large boilers for heating the seawater. That's why evaporation method is used to get salt from seawater. So with this, I end this module and we will meet again with many more interesting methods of separation.